Say this is our first part. This is the second part. And then say this is the third part. Now, of course, the problem says that one part is twice as long, and then one other part is 3 times as long. And of course, this graphical arrangement doesn't look like that, but it still serves our purpose. It doesn't have to necessarily look 3 times longer or 2 times longer, as long as our algebra is correct. Now, it says the second part is twice as long as the first part. So if the first part is x, and the second part is twice as long as the first part, so that's 2 times x. That's 2x. The third part is 3 times as long as the second part. So the third part, okay, the third part equals, it says 3 times as long as the second part. Or 3 times 2x, or 6x. Okay, so here we put 6x. Okay. Now we have 270 equals x plus 2x plus 6x. Okay, so first we have to find out what x is. Remember, the problem says how long is each part. It's not asking us how long is x. It's asking us how long is each part. So we solve for x by combining. First we solve for x, and then once we find x, we substitute the value for x back into the parts. So here, we add them all up. 6 plus 2 plus 1, that's 9x. So we have 270 over 9 equals x, or x equals 270 over 9. Okay? Now 200, now we know 27 divided by 9, that's 3. So this, we're going to get 30. Okay, 270 divided by 9 is 30. So we know that x equals 30. Okay? Okay? So now, substitute those values. And x is 30. 2x, that's 2 times 30. And here's 6x, we know that's 6 times 30. Okay? So the first part is 30. So the second part, 2 times 30, that's 60. 60 units. And then 6 times 3 is 18, so that's 180 units for the longest part. And there's our answer. Okay, now we have our next word problem, where we're dividing, or we're doing the same. It's the same type of problem. We have a car. Talking about a car driving from one city to another city. So we say a car drove from city A to city B in 2.4 hours at a rate or a speed of 55 miles per hour. The return trip was made in 2 hours. Find the speed for the return trip. Okay, so we know how long it took to drive and the speed at which the first trip took. So we're going to draw what we know. We don't have to draw the car. Don't think that you have to draw the car. All you have to do is draw a diagram of the path of the motion. So here's city A. And this represents, let's say that's city B. One city to another. Okay? So the car drove from city A to city B in 2.4 hours. So this line can represent 2.4 hours, and it also drove at a rate of 55 miles per hour. Okay? And it says the return trip was made in 2 hours. Okay? So from city B to city A, when the car returned, okay, the return trip was 2 hours. Meaning they must have went a little faster. Okay, so we know it's going to be faster. But we want to know, so how far, how many miles per hour, what speed, okay, did the car return at? Okay, so here we use what we know to find out what we don't know. What we're trying to find out is this, based on all the information that we have. But how is this information going to help us? So you have to understand the distance formula. In fact, that distance equals speed multiplied by time, or D is S by T. Okay? Okay, so you notice here, the distances between the cities are the same for the return trip, for the first trip and for the second trip. The distance between city A and city B is the same for both. Okay, so this equals the distance, and then this equals the distance. Now both the D are both the same. Okay. Okay, so we set up so we use this fact that both are the same. We say D1, we'll say D sub 1 is read as D sub 1. We'll say that's the first trip. That represents the first trip. The first trip. And then D sub 2 represents the return trip. Now the distance between two cities, let's say if the If that was Milwaukee and Chicago, the distance between Milwaukee and Chicago was always the same. You see, we're using this fact. We're going to use this fact to find out what we're looking for.